This section explains the isolation fault detection system, which is designed to detect faults in the insulation of high-voltage systems. An isolation fault detection system is a crucial safety feature in BEVs. It monitors the high-voltage circuits for any breaches or leaks of electricity from the isolated circuit to the vehicle chassis. This isolation is essential because high-voltage circuits can carry up to 800 volts, which can be extremely dangerous if they come in contact with the chassis and potentially cause electric shocks. The isolation fault detection system typically takes multiple actions when a fault is detected. The system stores specific error codes in the Vehicle Control Module, VCM, to aid in diagnosis and repair. It illuminates the malfunction indicator lamp, MIL, similar to a check engine light on the dashboard of an internal combustion engine vehicle, alerting the driver to a potential issue. In some cases, the system may disable the vehicle to prevent further damage or potential risks in case of a severe fault. This diagram displays a high-voltage battery safety system in a BEV, including an isolation fault detection system. The main components are the Hydropulse, Electro-Hydraulic Power Unit, EHPU, high-voltage battery, disconnect switch, sense line, chassis ground, and potential leak paths. The Hydropulse is a hydraulic pump that generates the pressurized fluid for the system. The Electro-Hydraulic Power Unit, or the EHPU, is a combined unit that houses the electric motor and the hydraulic pump. The high-voltage battery powers the vehicle. The safety disconnect switch isolates the high-voltage battery from the rest of the system. The sense line carries a signal from the system to the battery management system, BMS, to monitor the pressure and temperature of the hydraulic fluid. The chassis ground is the electrical ground connection for the vehicle chassis. Potential leakage paths are areas where the hydraulic fluid could potentially leak and come into contact with the high-voltage battery or other electrical components. The Hydropulse, or EHPU, generates hydraulic pressure for the vehicle's systems, but it is isolated from the high-voltage battery by the disconnect switch. The sense line monitors the hydraulic system and sends information to the battery management system, BMS. The potential leakage paths highlight the importance of preventing hydraulic fluid leaks that could compromise the vehicle's electrical safety. This system is crucial for the safe operation of BEVs by protecting drivers and technicians from potential electrical shocks. According to the Federal Motor Vehicle Safety Standards, every BEV in the U.S. must have a system to prevent electrical shocks after a crash or accident. Section S5.3 of the law specifically focuses on the electrical safety of high-voltage sources in BEVs. This section states that after each test specified in Section S6, crash tests and electrolyte spillage tests, each high-voltage source in the vehicle must meet one of the following requirements. A. Electrical isolation requirements. This involves maintaining a certain level of electrical resistance between the high-voltage circuit and the vehicle chassis, preventing current flow and potential shocks. The specific requirements depend on the DC or AC nature of the high-voltage source and the voltage level. B. Voltage level requirements. This applies to vehicles with a maximum continuous high-voltage source below a certain threshold, 48 volts DC or 25 volts AC. Vehicles meeting this requirement are considered low voltage and subject to less stringent electrical safety regulations. C. Physical barrier protection requirements. This involves using physical barriers to isolate the high-voltage components from the passenger compartment and other areas where occupants or rescuers might come into contact. This can be used in conjunction with electrical isolation or voltage level requirements. These are the key aspects of the Federal Motor Vehicle Safety Standards FMVS S5.3 regulations and their role in promoting electrical safety regarding the isolation fault detection system.